Close to the Sun, where temperatures soar and sunlight reigns unchallenged, a small, seemingly barren planet hides immense mysteries. Mercury, tiny, scorched, and long overshadowed by its larger neighbors, has become one of the most surprising subjects in planetary science. As the smallest planet in our solar system and the one closest to the Sun, Mercury might appear unremarkable at first glance. But appearances can be deceiving. Beneath its sun-baked crust lies a world of strange phenomena, powerful forces, and cosmic secrets that continue to challenge our understanding of the solar system's formation and evolution. Mercury's story is one of paradoxes. It is both ancient and dynamic, blisteringly hot on its surface yet hiding frozen water in its shadows. It rotates slowly yet races around the Sun. It's small in size but dense in composition, denser even than Earth when corrected for gravitational compression. All of these contradictions have made Mercury a planet of deep scientific interest. For centuries, Mercury was little more than a dot of light in the sky, visible only at dawn or dusk. Its proximity to the Sun makes it difficult to observe from Earth, as it is usually lost in the Sun's glare. As a result, very little was known about this elusive world until the 1970s, when the first spacecraft was sent to investigate. The Mariner 10 mission, launched by NASA in 1973, became the first spacecraft to visit Mercury. It performed 3 flybys between 1974 and 1975, capturing over 2,700 images and revealing a world that, at first glance, resembled our Moon, covered in impact craters, ridges, and scarps. But there were startling differences too. The biggest surprise came when Mariner 10 detected a global magnetic field, something that small planets were not expected to have. This suggested that Mercury possessed a molten, metallic core large enough to generate such a field, an idea that reshaped planetary science. But after Mariner 10, Mercury faded back into the shadows. For more than 3 decades, it remained largely unexplored. Then, in 2004, NASA launched the MESSENGER mission, short for Mercury Surface, Space Environment, Geochemistry, and Ranging. This was a far more ambitious endeavor. Instead of merely flying by the planet, MESSENGER would enter orbit and conduct detailed observations over several years. What it uncovered would revolutionize our understanding of Mercury. MESSENGER showed us a planet with a core that is staggeringly large, making up about 85% of the planet's radius. For comparison, Earth's core accounts for about 55%. This raised major questions. Why does Mercury have such a disproportionately large metallic core? One hypothesis is that early in its history, Mercury experienced a colossal collision with another planetary body, which stripped away much of its outer, rocky layer. Another possibility is that it formed in a region of the solar system where only heavy elements like iron were able to condense and accumulate. Further surprises emerged when MESSENGER analyzed the surface composition. It detected unexpectedly high levels of volatile elements, including sulfur, potassium, and sodium, elements that should have been lost to space if Mercury had formed under the intense heat expected so close to the Sun. These discoveries directly challenged long-standing models of planetary formation and suggested that Mercury either formed further from the Sun and migrated inward or that the early solar system was far more complex than we once believed. MESSENGER also discovered signs of past volcanic activity, with vast smooth plains formed by ancient lava flows. This indicated that Mercury, once thought to be geologically dead, had a lively interior in its early years. More intriguingly, the spacecraft identified pyroclastic deposits, evidence of explosive volcanic eruptions powered by volatile gases, something even more surprising given the planet's size and expected depletion of lighter elements. But perhaps one of the most astonishing findings from MESSENGER came in 2012. Evidence of water ice in the permanently shadowed regions of Mercury's polar craters. Even though Mercury is the closest planet to the Sun, certain craters near its poles never receive direct sunlight and remain at temperatures below 170 degrees Celsius, 274 degrees Fahrenheit. In these frigid environments, water ice can remain stable for millions or even billions of years. Alongside the water ice, researchers also found dark organic-rich material, possibly carbon-based compounds deposited by ancient comet impacts. These materials are the building blocks of life, and their presence on Mercury suggests that even the most hostile environments in our solar system might preserve traces of organic chemistry. It also implies that the ingredients for life are more widespread than previously assumed. One of Mercury's strangest characteristics, however, lies in its relationship with time. A year on Mercury, its full orbit around the Sun, lasts only 88 Earth days. But its day, the time it takes to complete one rotation on its axis, lasts 176 Earth days. That means a single solar day on Mercury is twice as long as its year. This unusual dynamic is caused by a 3-to-2 spin-orbit resonance, meaning Mercury rotates 3 times for every 2 orbits around the Sun. As a result, the Sun appears to perform a strange dance in the Mercurian sky, rising, pausing, moving backward briefly, and then continuing its path. For any observer on the planet's surface, time would seem completely alien. In 2022, scientists examining MESSENGER's data uncovered another mystery: subsurface nitrogen trapped deep beneath Mercury's surface. Nitrogen is a vital component of Earth's atmosphere, but its presence on Mercury, where atmospheric gases are expected to have long escaped into space, suggests that Mercury might once have had a thicker, more complex atmosphere. What could have created this atmosphere? Could it have supported more stable surface conditions in the distant past? While life as we know it is unlikely to have ever existed on Mercury, the presence of nitrogen opens new avenues of exploration into the planet's evolutionary history. Adding to these questions is the discovery of hollows, irregular, shallow depressions on Mercury's surface that appear to be geologically young. These features are thought to form when volatile materials in the crust vaporize due to solar radiation, leaving behind collapsed areas. The fact that such activity is ongoing today suggests that Mercury is still geologically active in some way. The next phase in Mercury exploration is already underway. In 2018, the Bepi-Colombo mission, a joint venture between the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, was launched. This dual-orbiter mission will arrive at Mercury in 2025 and will bring a suite of advanced scientific instruments to study the planet's surface, magnetosphere, and internal structure. One orbiter will focus on the planet's geology and surface composition, while the other will examine the magnetosphere and its interaction with the solar wind. Bepi-Colombo is expected to map Mercury with far greater precision than MESSENGER, measuring gravitational variations, scanning for more signs of ice and organics, and helping to determine how such a small planet can still maintain an active magnetic field. It will also investigate how Mercury's unique conditions, such as its proximity to the Sun and extreme temperature changes, affect the stability and evolution of materials on its surface. Why does this all matter? Understanding Mercury is not just about understanding one planet. It's about uncovering the history of our entire solar system. Mercury preserves a record of the conditions that existed during the early formation of the Sun and its surrounding planets. By studying its core, its magnetic field, its surface composition, and even its ice and organic compounds, we can piece together the story of how rocky planets like Earth came to be. Mercury serves as a time capsule from an ancient era, one marked by intense heat, violent collisions, and the birth of planetary systems. It challenges our assumptions, reshapes our models, and reminds us that even the most overlooked corners of our solar system can hold treasures of knowledge. As we await Bepi-Colombo's arrival, one thing is certain: Mercury's story is far from over. In fact, it may just be beginning.